Hello there. In this video, I'm going to take a crack at proving the addition cosine identity. So we're going to be cheating again a little bit in that we know the end result, but we're going to use the same diagram that we did, and we're going to use the same approach that we did in the addition sine identity. So if you don't know what that approach is, go back and watch that, because I might not be as... I'd probably be expecting you to have watched that video to know the full approach, okay? So the first thing we're going to do is try and get cosine alpha plus beta in terms of the segments of this. Now, alpha plus beta is in this triangle right here. And so therefore, cosine being adjacent over hypotenuse is AB. So cosine alpha plus beta is equal to AB. But the hypotenuse is still 1. So basically just AB. Well, again, we've got a minus sign in the formula. We need to work that in somehow. So AB, notice, if we take this segment here, AC, and notice that's AB plus BC, okay, great. We can go ahead and subtract BC, and then we get AB is equal to AC minus BC. We've worked our subtraction sign. I'll be a little bit more prompt about getting rid of old notations on the diagram so it doesn't get too cluttered in this video. Okay, so let's work on the pieces one by one. Let's go ahead and get cosine alpha. So cosine alpha would be this one right here. That would be the full length of AC. So cosine alpha adjacent would be AC over our segment AE. And using the same approach we did in the previous video, let's go ahead and multiply by AE, because I know that cosine alpha has to be multiplied by something that will ultimately be cosine B. So we get AC is equal to cosine alpha times AE. Well, that means that AE has to be cosine beta somehow. So let's go ahead and grab that. We're going to work on cosine beta, and that's this angle right here. So adjacent again would be AE. Cosine beta is equal to AE. Now it's got the 1 as its hypotenuse, so over 1, which is just AE. So that means we can get, I'm going to go ahead and put it as AC is equal to cosine alpha times cosine beta. Great, we're half done already. Okay, I'm going to put that in a box to keep better track of it. Okay, so that means we need to work on the signs. So sine alpha, so that would be this side right here. That would be CE over the hypotenuse AE. Well, that doesn't look like, and this is a similar trap that I fell into when I did this sine addition formula. That's not going to do us any good. So instead, what I'm going to do is I'm going to go over to this angle. Again, if you want an explanation of how that's alpha, go back and watch the other video. But the opposite is DE. So I'll write this over here, sine alpha is equal to DE over EF, which would be the hypotenuse. Okay, and I won't write it out, but sine alpha times EF is equal to DE. Now, why is DE important? Well, if we look back, we have BC here. BC is the side opposite on a rectangle of DE. So note, we've got BC is equal to DE, okay? So we could write that down if we wanted to. That is BC. Okay, great. That just means I have to take EF and turn it into sine beta. So I'll do that down here. So sine beta is this EF. Great, working out so far. So sine beta is equal to EF. And notice that's got the same hypotenuse as right here. That's the 1, which is just EF. Okay, great. So that means we over here, I'll write it down here, we have BC is equal to sine alpha times sine, almost did it again, beta. So let's put a box around that, because now we have the pieces that belong to this. AB was cosine alpha plus beta. So cosine alpha plus beta is equal to our first box, which was the cosine alpha times cosine beta minus the sine alpha times sine beta. Thanks for watching.